Okay, now we'll check how to solve a puzzle problem using a BFS algorithm. So in this program, we are having only four functions. If we understand this four function, then this program is very easy. Okay, what are the four functions that we are having is print board, move blank, is goal, and BFS. So these are the four functions that we are having. And if we understand this one, it is very easy. Okay, so now first thing, our program is having two main states, that is initial state and goal state. For those who are unaware of this 8 puzzle, we know that it's a 3 by 3 board where we'll be having a 9 elements. Out of that, one will be a blank elements. In our programming, that blank element we are going to call as 0. What is the use of this blank element is we are going to move initial state to a goal state by only changing the position of this blank space to reach our destination as goal or goal state or destination. So that is how it works, and it is having only four ways to move. That is up, down, right, left. Only four ways it can move. Okay, this is very basic intro regarding to our 8 puzzle. Now we'll come to our program only. Just after this initial state and goal state, we are having the very first line is print initial state. Now you may wonder what is this. You can also call this initial state as a list of list, or you can call as a two-dimensional matrix. Okay. Uh, Next, after this print initial state is there. Now, as it is, this statement will be executed initial state in the output console. Next one, the very next line, we are having a print board initial state. Now, what is this print board initial state? Now, this print board is a function, and it is calling what parameter is going to take means initial state. It is going to take as a parameter, and it is going to the function definition, that is a print board. So this is what our function definition print board. So now what this function does for us. So we'll just have a look at it. Now it is going to carry our elements, right? What are those elements? That is our board. So we are having one initial state, two, zero, and three, four, five, seven, 8, and 6. So these are the this is the board that we are having passing as a parameter, right? Now after inside this function, we are having a for loop. So for loop is iterating over board and the variable that we take as a row. Now the first value of this row will be occupied by 1. So now row will be having one value. Now the very interesting line lies over here. That is print of uh, space dot join map of str data str comma row. What is this means? This we are going to call as a separator. That is space we are using to separate. Now dot join of map of string. What is the row value actually? Now the initially row value is 1. Now this numeric is converted into a string. Why it is converting into string means the map function, it is a data type string. So whatever the values now row will be iterating, that every value will be converted into a string. Now you may get a question that why we require to construct convert into a string. So this join function works only on string, so that's why we need to convert the entire values into the string format. Okay, so that's how it is done. That is why we are using. Now what is the use of this actually? Now first time it is 1, next it will take 2, next it will take 3. So like that all the elements, like that all the elements will be uh, iterated. And how it is going to represent, when it is going to represent as 1 comma 0, 2 comma 0, and 3 4 5. Instead of all these square brackets or the list format, it's just going to give us a clean visualization of 8 puzzles. Sir, what I'm talking about, I'll just give you. So I'll just scroll it down. You'll understand. Now you may get also doubt that I'm going to print as an initial state as it is. So now what is the initial state and print initial state as it is? So what it is going to display. So this is not a way of clearly visualizing 8 puzzle. So that's why we are using that join function and map function so that we can visualize like this. So to visualize a clear format of 8 puzzle, that we are going to use a join and map. There is nothing more in that print board function. There is also another way, but right now we are going to choose this join and map function to display our print board, that is a goal state and initial state. Okay, uh, we'll check now. So this is how it is going to convert, and it is going to display. So after that, we are having a very next, that print board will be executed 2 times. for printing a initial state and one is for printing the goal state. Now after that, very first is that our main function call. We are taking a solution path variable and we are going to assign to a BFS initial state comma goal state. Now this initial state and goal state we are going to take as a parameter and we are going to send it for a BFS function. So what is this BFS function? That initial state and goal state were actually accessed by this initial board and goal board. And we are very first line of our BFS function is we are having is a visited equals to set. So now visited is a variable. Now we are going to convert into a set. Okay, we are going to convert into set. Now some you may ask that why we are going to convert into a set. So while we are going to traverse, there will be some situations where we are going to get into the same iteration or same kind of a move. So to avoid that, we are going to use a visited set. So you know that the basic principle of the set is it does not allow duplications, right? So that's why we are going to use a set. So in the coming exploration, you will understand the use of the visited. But right now, you understand that to avoid duplications, we are going to use visited. Okay. So the next one is Q. Q we are having q is a variable and this q we are going to assign as a dq. Why we are using dq now? So dq is a double-ended queue, so we can insert and delete from left and from end we can insert. Now this is going to have the value of initial board. So dq we are going to convert into an initial board and this empty path, this is nothing but a path to detect path, that is left, this empty left, right, okay, down, up. So to decide this directions, we are going to make a empty list over here. Okay, so you'll understand where we actually use. Now this dq is imported from collection frameworks, that is, sorry, collections, from collections import dq. So we cannot be have by default, so you need to use this line. We want to use our dq. Okay, so fine. Now Q equals to dq of initial board. Now what Q is having means Q is now become as a double-ended Q, and it is holding a or our initial board. The initial board is nothing but our initial state only. That is, it is having the initial board. Now, okay. Now while Q, now Q is having one value. It is having board, so it becomes true. Now it will be entering into the while block. So now this while block, what is the very first line of this while block means? Current board, one more variable we are going to take, comma path equals to q dot pop left. Now what is happening actually? See here, current board we are going to access, or that it is going to assign the q value whatever we are having over here. So this initial board is present in the queue. So using q dot pop left, so using q dot pop left, we are going to have the initial board as a current board. Using what? Q dot pop left, we are going to have a initial board to a current board. Now right now path is empty since it is not having any value, so path is empty, we are not having anything. So but you remember current board is nothing but a initial board, which initial board is nothing but a initial state. Okay, the current board we are having some value. Now the very next line is one more function we are having. If is goal, current board comma goal state. Okay, what it is going to check means here it is the goal state. Now it is going to check is our board equals to goal. Now whatever the initial board is, we are going to pass like a current board is equals to goal state. It will check. So it is not equal. So it will become the entirely false, and this rest of the block it will won't be executed. Next it will come to the visited. Now see the magic. What happens? Visited dot add a tuple of map of tuple comma current board. You may ask why we required all these kind of things. Okay, can't we add simply add of current board or add of this thing, right? You may be having that doubt. That is very common. If you get this doubt, good, you are going to understand. So visited is what our empty set we were having, right? So we are going to add a current board to it. What we said, visited is a set, and whatever the current board, it was a list of lists. That is nothing but our 2D matrix. We are going to convert that into a tuple, and we are going to store into the visited variable. See, why we want to store in the tuple means, like list, they are hashable and there will be chance of mutable. So to avoid this complication, we are going to convert into a tuple the entire current board. So far it is enough. don't dig further, you'll get confused. So for easier purpose, you can assume that it is used to store in the set. Okay, tuples are very easy to store in the set. That is fine for you. Okay. Okay. The very next thing we are having is a for loop, and a direction in up, down, left to right. Okay. Now direction we are having for loop, and the direction right now will be holding a up direction. Again, one more variable we took, that is new board. New board equals to move blank of current board. We know that current board and the direction. Direction is up. Current board we know, and the direction is up. Here everybody is clear. Now what is this move blank? Move blank is again one more function call, and we'll move to a function definition. Move blank function definition. You know that you remember that current board and direction. Direction is up, right? Okay. Now check here. Def board we are going to pass, and what is our direction is up. So we'll just write this board so that it is easy for us to visualize. Okay, what was our board? 1 2 0 and 3 4 5 7 8 and 6. This is our board, and here it is very important for us to know the index also, that is 0 comma 0 0 comma 1 0 comma 2 1 comma 0 1 comma 1 1 comma 2 2 comma 0 2 comma 1 and 2 comma 2. This is the index, and this is the board that we are having. Now next, one more board we are going to assign using a list comprehension. So it's just the copy the entire board to new board. There is nothing. We are having one for loop over here. It is going to iterate over board, and it is going to copy row wise, and it is going to store into a new board. Okay, that is what we are going to do over here. Now, it's a very basic thing that if you want to traverse into a two-dimensional matrix, or you want to move, or you want to enter into a two-dimensional matrix, or then we require two variables, that is I and j. One is for row and one is for column. So this is very basic, right? So now for I in range of 3 and for j in range of 3, so the range function, we know that it will starts with 0. Okay, the range function will starts with 0. Now I will become 0, j also will become 0, and if new board I comma j equals to 0. So what is this I value and j value? I value is 0 and j value is 0. So what is this 0 and 0? 0 and 0 is having 1. Now 1 equals to 0. No, it is not true. So that if block is not executed. So it will control goes to back to the inner for loop. Now the j value will become 1. Okay. Now 0 comma 1 0 comma 1 equals to 0. 0 comma 1 equals to 0. No, it is 2. It is not executed. Again it will go. The j value will be incremented. Now it will become 2. Now 0 comma 2 equals to 0. Yes, you can take a clear look over here. 0 comma 2 is equals to 0. This if block will execute, and now next this if block will be checked. Okay, now first block what is having, if direction equals to yes, yes, direction is up, and logical and I greater than or equals to I greater than 0. Is I greater than 0? No, the inner for loop is 0. Is greater than 0? No, it is not. So it cannot be executed. So again it will go to the control, goes back to this for loop. This inner for loop is uh, exhausted, its range. So the I value now will become as 1. Okay, now you can check here, when I value will become 1, it cannot find the 0 or our blank space. So it is a waste. So it won't execute anything. So it will directly return to our function. Where is our function call? Where is our